Today we're going to talk about 4.6, which is talking about slope and looking at the relationship between parallel and perpendicular lines. We'll talk about writing equations of lines, dealing with our altitudes and our medians and perpendicular bisectors. And so we've been talking about writing equations of lines and reviewing what those things look like in class. First example here, if triangle ABC has vertices of A, B, and C here, determine if it is a right triangle. So first off, we need to understand that if, in order for it to be a right triangle, we know that it has to have a perpendicular set of lines, and perpendicular lines have opposite reciprocal slopes. So first off, let's graph this these sets of ordered pairs. There's A, B, and C. So here is our triangle. In order to determine if it has a right angle in it, we can find these slopes. So if we first find the slope of AB, plug in those ordered pairs into our slope formula. And we get a slope of -2. We could then find the slope of AC. And when we find that slope, it simplifies to 1/2, and we can clearly see here that these two slopes are opposite reciprocals. Therefore, yes, this is a right triangle, since angle CAB is a right angle. In our next example, determine if ordered pairs are collinear. In order to determine if points are collinear, that means they need to lie on the same line, which means they should have the same slope. So we're going to first look at these on a graph. A would be roughly up there. B would be right here. And C. So in order to determine if they are on the same line, let's find the slope. So first off, let's find the slope of this is A, B, and C. Let's find the slope of AC. And when you plug in those ordered pairs, you get a slope of 8/3. You can then find the slope of AB. And you plug in those. You get a slope of 14/5. And these slopes are not the same. So points are not collinear. For the next example, we're going to determine the value of R given these 2 points. So all we're doing is plugging our points into the slope formula, except we are given the slope and we need to find one of the coordinates. So we need to first remember what the slope formula is, and then plug in what we have. We know the slope is 1/4. Plug in our ordered pairs. And so when we do that, we're going to get 1/4 equals 2 over R plus 4. And we know when we solve that, we will get R has to be equal to 4. So we can get our coordinate by plugging in to the slope formula. Midpoint, slope, and distance are review. Let's just make sure we have these down. So if you need these three things, mark them down. This is a new one. This one is something we have not gone over before. And so we need to talk about the distance from a point to a line. So we're talking about the distance from a point to a line. This is first off the absolute value. And then we have our x1 and our y1. That is the point that we have. So from that point, and then to the given line, the line that we're talking about has the a, b, and c value. And where that a, b, and c value come from is the standard form equation of the line. And that's a standard form where it's plus c equals 0. So we need to find the equation of the given line that we're trying to find the distance from to that point, and we need to find it in standard form. Some other things to review that we do already have. These are the three equations of lines that we have reviewed. So if you don't know those, take a minute to write those down. So let's add a question now. Let's practice the distance from a point to a line. So the given point that we're going to talk about is 2, 1, and the line is 5/3 x plus 9. So visually what that looks like is we have an ordered pair, and then we have a line that starts at 9, has a slope of 5/3, so it's roughly something like this. And we want to find out how far that point is to the line. So the easiest way for us to do that is to use our new formula, the distance from the point to the line. Now we have the point here, so this is our x1 and our y1 in our formula. We need to write this equation of the line in standard form. So we're going to move the y to the other side. And then we need to clear the fractions by multiplying everything by 3. So now if we recall our new formula, I will copy down over here. We bring back our ordered pair of 2, 1. This is our x1 and y1. And then we have our a, our b, and our c. So now once we have the formula, all we are doing is plugging things into the formula. So once we have everything plugged into our formula, all we are going to do then is simplify. When we do that, we get the absolute value of 34 on top, and we get the square root of 34 on the bottom. We can simplify this by rationalizing, multiplying the top and the bottom by the square root of 34. And root 34 times root 34, we get root 34, or just the number 34. And we can cancel out, and the distance from this point to the line is the square root of 34. A couple examples dealing with writing equations of lines. So we're going to be practicing with medians and altitudes and understanding the visual connections here in writing equations of lines. First off, WEL means write equation of line. Then we have to understand what the median means. So if I'm going from A to BC, that means I'm going to the midpoint of BC. So the very first thing I need to do is find the midpoint of BC. When I find the midpoint of BC, I get 3, -1. So now when I'm writing the equation of the line of this blue median, I have my 2 points now. I have -9,6 and 3, -1. So if I'm writing it also in point slope form, the first thing I need is the slope. So I need to find the slope. We'll call this point M. I need to find the slope of my median AM. And I get a slope of -7/12. Now when I'm putting it into point slope form, I need the slope, which I have, and then I need a point. Well, I have 2 points, so I can choose either point to write the equation of the line. And because we have both points, and it said point slope form, either one of these would be acceptable. We're talking about an example with the altitude from B to AC. We need to know that the altitude means it starts at the vertex B and it goes to the opposite side where it makes a right angle. So that right angle tells me that it's opposite reciprocal slope. Opposite reciprocal slope, though, of AC, because that's where it is perpendicular to. So I need to first find the slope of AC and then take its opposite reciprocal. So finding the slope of AC, plugging in those ordered pairs into my slope formula. I get a slope of -1. But I need to take the opposite reciprocal slope, which means my new slope of the altitude is +1. Well, I then have my point, so I can plug in these into my equation of the line, and we're talking about slope-intercept form here. So I can plug in my y value, my slope, and my x value, and I can solve for my y-intercept, which I will get is -3. I now have everything I need for the equation of the line. There are 3 more examples that you're going to need to finish here. When we talk about perpendicular bisector of AB, that means it's going to go through the midpoint of AB and it is perpendicular. So you want to write the equation of the red line there. How would we do that? I will write the answers to these in just a second. So this next one here, the length of the median from A to BC. So I'm going to draw the median A to BC. That means I know that I have the midpoint, so I need to find the distance of that. Go ahead and pause the video and solve these, and then the answers will be there in a second. Here's answer number 5. Number 4. and number 3.